Hello, everyone. Another session, module 18, CCNA 3, wireless LAN configurations. So after the last module that we did, wireless LAN concepts, that was the foundation of what we'll be doing in this session. Basically, with wireless LAN concepts, we introduced what the wireless LAN is, what are the components that we have from the NICs, the access points, the wireless routers, the controllers. We discussed the protocols that are used in communications between, more specifically, the AP and the controller that is capable. We also got into discussing the standards, the different standards that we have, the different channels that are used, security. So in wireless LAN configurations, we're going to be looking at the main objective being implementing a wireless LAN using a router, a wireless router, and a controller. We're going to configure a wireless LAN to support a remote site, configure a controller to use the management interface and PSK authentication, configure the controller to use the VLAN interface, DHCP server, enterprise authentication. Then lastly, look at troubleshooting methods, the methodology of troubleshooting wireless configuration issues. Right. We're going to start with the wireless router. I think basically a summary of the whole module, we're going to see how do we configure the router, that is the wireless router. We're going to see how to configure the controller. We're going to see how to configure as well the access point. And lastly, the clients themselves. How do you configure clients so that they can get access to the network? This is basically a summary of this module. Starting with the wireless router. Remote workers, small branch office, home networks often use small office and home routers. These are integrated, these integrated routers typically include switch, wired clients, a port for an internet connection. Wireless routers typically provide security, DHCP, NAT, QoS, as well as other features. So the first device we are going to be configuring the wireless router, we introduced it as well in the last module, wireless LAN concepts. A router basically provides internet access to wired and wireless clients. In a normal setup, if you can see at this diagram, we have here our internet, we have the modem, and the modem basically what it does, converts analog digital to digital signals. It's much easier to transmit analog signals. Not much easier, but let me say most of the signals that are being transmitted over long distances, they are analog. They can be analog. Therefore, for us to have the digital format, which is readable by the clients that uses the information, there is need for that conversion. So before you have your router, you need to convert the analog signal. If it is already digital, there's definitely no need for it. But if you have an analog signal, then there is a need for a modem that converts the analog signal to digital. Then the digital signal is easily readable by your router and by the clients on the network. So that's why we have a modem right here. Now, a normal setup, in a typical setup, you can have this modem and it converts analog to digital. That's one. So you have a port which converts analog to digital. Then you can also have ports which can provide a wired access to the internet. But that is if you have a modem that offers that is that capability. Sometimes you have a modem and a wireless router separate. So the router is connected to the modem, then the router is responsible for giving access to wired or wireless clients, giving internet access to wired or wireless clients. So the router, basically what it offers, we can see from here, it offers more services than the modem. It offers security, DHCP, address translation, and lastly, quality of service. Right. Basic network setup. So here we're looking at what is the basic network setup once you get your wireless router out of the box. Let me see. Right. Once you get your wireless router out of the box, what is the basic setup that needs to be done? So we have logging in into the router using the web browser. We'll get to that. Changing the administrative password. Log in with a new administrative password. Change the default DHCP IP address. Renew the IP address. Then log in again. So the steps that we have here, basically the steps that we have here. You have purchased your wireless router. You've installed your network. There you have a simple setup. So let's say this is your wireless router. Let's say this is your PC. We'll make this PC our admin so that we can be able to access the wireless router and we can be able to make some configurations on it. Then we can have probably a broadcast, or then we have other clients that are connected to the wireless router wirelessly. Here we have our modem, then here we have our internet. Once you purchase your wireless router, a few things that needs to be done. You access your router via the browser. How you find the IP address of the wireless router. Probably rinenge riripo rakanyorwa pa box rinonyane wireless router rako, or sometimes if you search the internet, default IP addresses for the routers anenge aripo. You access your browser, you type in the IP address 168.0.1. You type in the IP address of the wireless router. That's how you get access to the wireless router. Once you get access, this is what you get. All right, logging in into the router. There's an IP address here, turning access. You enter in the passwords, the username and the passwords. These are all defaults, by the way. So almost every router, it has default passwords. And the reason why we are going to be changing them, as you can see, these 2 points, change the default administrative password. The reason why we are going to be changing them is because by default, probably everyone who deals with networks knows what is the IP address of the router, default IP address, what is the default username and the default password. So the first thing that you do once you log in is to change those things. So this is the login page. We have logged in. These are the menus. These are the tabs that we have. As we start to do our configurations, we'll browse through all these tabs. But for now, it's just explanation of what we are going to be seeing. Right, so if you want to change your password, just a minute. If you want to change your password, let me move this. Right. If you want to change your password, you can see we have the administration tab there. You go to the administration tab. From the administration tab, that's where you can see the router password. Then you can change. You change the router password. Therefore, it's no longer default. First thing that you do once you get your wireless router out of the box. If you don't change that, someone can easily get access to your network, and that can become a problem. Changing the default IPv4 address, DHCP IPv4 address. Like I said, in the example, when we started to log in, we used this password 168.0.1. You can see from this one, this is the default. Okay, it's right there. Okay. Right here. This is the default IP address, 192.168.0.1. You need to change that IP address. And how do you change it? You change the DHCP default IPv4 address. In this example, it was changed from 192.168 to 10.10. So instead of having to log in using 192, once I have changed it, it means I can use 10.10.10.1. That becomes my IP address that I use to log in. DHCP, when you are connecting wirelessly, we said we have our wireless router. It provides wireless access to our clients PC1, PC2, PC3. How do these wireless clients get their IP addresses? They get their IP addresses from the DHCP settings that are configured on this router. So in the example where we had 192.168.0.1, it will mean probably PC1 will get IP addresses from this range. 192.168.0, probably .10, .0, .11, .0, .12. The IP addresses from this DHCP setting. But once you change to 10.10.10, you can see here the range. Starting IP address, this one started at 100. So the IP addresses that will be given to your clients will start at 10.10.10.100.101.102 up until .150, 149, because the maximum number of addresses that we have there is 50. So two things that we can learn from this DHCP setting. One, changing of the default IP address so that your networks cannot get easy access to your router using the default. Once you change that, it means the clients, they'll be getting IP addresses from the DHCP settings that you have configured. Very important. Wireless clients, they get, even wired, they get IP addresses from the DHCP settings that you configure. And this is all the DHCP settings that we configure on the wireless router. After you've changed your IP addresses, this is your router. Let's say this was your admin, right? I was using this admin to get access to this router over the web browser. Once you change the DHCP settings on the router, it will mean the IP address on the admin, if it was set to get its IP address dynamically via DHCP, it will change as well. So probably you had 192.168.0.100 here. And here, the DHCP settings have now changed to 10.10.10.0.1. Therefore, you need to renew your address. This will no longer be the address here. Once you renew, you probably get 10.10.0.100 as your new IP address. If you do not renew, then there will be no communication, because the IP address that you'll be using as your admin, it will be different from the network that is being used by your wireless router. So renewing, using IP config renew, you renew the IP address on your admin or on all the wireless clients for that matter, so that they get addresses from this pool, 10.10.10, I think it's 10.10.10.0. After you renew, log in again. I think that was the last step. After you renew, you log in again. Renew IP address, log in the router with the new IP address. So this is the starting point of configuring a wireless router. There is no much configurations that you need to do. One, just change the default passwords that are used to log in, change the default IP addresses, therefore changing the default DHCP pool, renew the IP addresses of the clients, then you start getting access to your network. Moving to basic wireless setup. Basic wireless setup includes the following steps. View LAN, wireless LAN defaults, change the network mode, identifying the 802.11 standards, configure SSID, configure the channel, ensuring no overlapping channels, configure the security mode, selecting open, WPA, PA2, personal and enterprise, configure the paraphrase. Right, once we've done the out-of-box configurations, changing the default administrative passwords and changing the default DHCP settings, now we can start configuring wireless router redu kuti rifunctione as a provider wireless network, Wi-Fi basically. The first thing, view the wireless LAN defaults. Basically, what we have here is understanding all the tabs in the panel. Understanding all the tabs, that's your starting point. Kuti pa setup, pa wireless, pa security, access, what do we have? When we do the actual configuration, we'll go through all that. Here we have tab wireless that we have. In the LAN defaults that we have, you can see the network mode is auto. The SSID is default. That's the name of the network. It's default. Is it broadcasted? Yes, it is being broadcasted. The channel that we are using channel 1. The bandwidth is selected as auto. We have two bands that we have, the 2.4 and the 5 gigahertz band. So we are just seeing the defaults that we have on our router, the wireless router. These are the defaults that we have. You need to understand when we say the mode, when we say the SSID, what is it? So that when you change those configurations, you understand what exactly are you changing. The same thing if you go to the tabs of security, we'll get there. Understand every tab, every menu, every pop-up that is there, so that you understand if you change that, what are the consequences to the network. Changing the network mode. So the network mode, as you can see, auto, we have N only. The network modes, these are the standards that we discussed when we introduced our 802.11. We had A, we had B, we had G, we had N, we had AC. These are all, I think we also had AX there. These are the standards that we use. So this is the network mode. Here we don't have all of them written one by one, 802 A, B, no. We have N, which offers 2.4 and 5 gigahertz band. We have legacy. Legacy basically offers all of this. It offers all of this, I think, except, let me see, except, I know it offers N, I know it offers B. I think legacy offers quite a number of these standards. Not all of them, but quite a number. In this section, we selected legacy. It's safe to select legacy because the latest modes, the clients that, the mode that the clients use is probably part of the legacy that we selected. So it's safe to use legacy. So I think I've just confirmed legacy. It has A, N, and AC. These are the modes that are used by legacy. So this is legacy. So it means if your clients are using A, they can be able to use legacy. But if you choose N only, for example, the standard they'll be using will be standard 802.11 N and only that. If the mode is disabled, then that's another issue. Our network is probably not working. Right. The SSID, so this is changing the mode. You can change the mode for the 2.4 gigahertz and the 5 gigahertz frequency bands. These are two different, we'll see later on. We can configure these two bands as two different wireless networks. I can configure this as its own network, this as its own network, but on the same wireless router. So it means I can have two networks, the 2.4 and the 5 gigahertz on that same wireless router. We'll get there. That's why you have different settings. Here we have its own settings for 2.4, For 5 gigahertz band, it has its own settings as well. Configure the SSID. This is just changing the name of, this will be the name of your network. What will be broadcasted? Kana ndine phone yangu ndoda connected to the internet, ndaisa Wi-Fi yangu, what is the name that is popping up there? That needs to be changed. This one was changed to OfficeNet. This one was also changed to OfficeNet. It does not have to be the same. Can also configure the 2 bands as 2 different networks. You can change this one. This can be office department like this. It's not always you have to name them the same thing. It's not always they have to have the same settings. No, they should not have the same settings because they can be configured as 2 different networks. One using the 2.4 frequency band, gigahertz band, the other one using the 5 gigahertz band. So this is the configuring the SSID. You need to change that. Then we go to the channel. We discuss the channels that we have. 2.4 gigahertz, it has 11 channels that they use. In this example, we selected channel number 6. If you have your wireless router very close to your APs, if they are very close to your APs, it will mean this will probably be in channel 1, this will be in channel 6, this will be in channel 11. We discuss that in the concepts. If the channels are overlapping, to avoid interference, you use non-overlapping channels. And the non-overlapping channels we have is 1, 6, and 11. So this is where you select the channel that will be used by your network. Configure the security mode. Right. Here you configure if a wireless client wants to get access to your network. For authentication, what will happen? Choosing the mode that you are going to be using for your wireless router determines the type of authentication that is going to be that your network is going to have, and the type of encryption that your network is going to have. So as I said in concepts, WPA, not safe at all, not secure. For small home networks, you can use WPA2 personal. What is PA2 personal? What you have a PSK, that is a shared key, which is used for authentication. When a password to enter the network, that is the PSK, right? And the encryption protocol that it uses AES. So that is for personal. If we are using enterprise, if you select enterprise, it now means you have a server, the radius server. That is where you have introduction a radius server. For authentication, every client has a username. Every client has its own password for AAA, so that we have authentication, authorization, and accounting. You can audit. Utapinda network ndiani, apinda achite, aita access to what. So 2 different types of security setups that we have, security settings that we have. In this example, obviously, they chose WPA2 personal. It means there'll be a password that will need to be configured. So I can see probably that's the next thing that we do, the passphrase. After you've configured WPA2 personal, then you have your password there, Cisco123 in this example. That's the password they used, right? So client can get access to the network. SSID ari kuziva OfficeNet, click pa OfficeNet, osangana nekunzi tipe password, the password yaunoisa ndio yaconfigure apa, then you get access to the network. Configuring a wireless mesh network, right? So the first, apa patatopedza ne-wireless router, very simple settings. Mamwe ese, navigating all the tabs dziri apa idzi, it comes with experience, with the learning, but atatoita izvezvizvi, share wireless network yedu, wireless clients can easily connect to that network. So in summary, the things that we did, we changed the default settings dziripo so that munhu wese cannot get access to our network because by default settings they are known. So we've changed that. That's one. Two, we have created our wireless line. We have created Wi-Fi here. How did we do that? To create the SSID, to create the security settings so that we get the password. We have also created my settings, a mode, the channels that we are going to be used. What else? The channel that we are going to be used. I can see from here. And basically, I think that's it. That is what we have done. Change the default settings. Tabata broadcaster network yedu. My clients can now get access to the Wi-Fi. Navigating could set up panechi, security, manage access, application gaming, experience and learning and practice. You get to understand what is all there. Since we've got access to the internet, that's good enough. Configuring a wireless mesh network. Right. In a small office or a home network, one wireless router may suffice to provide wireless access to all clients. If you want to extend the range beyond approximately 45 meters, you create a wireless mesh. Create the mesh by adding, yes, Makucho. Yes, boss. Yes, question.
Yes, yes, I have a question, but you know,
Right, and
hello?
if you have a question, probably Mike here doing it. If you have a question, you can type it by chat. If it's not too long, because I'm soon as going.
All right. Issue yangu iri pama-frequency na both.
Pamachi?
Yes, pama-frequency.
Yes, my frequency, my channels. My channels, they my frequency bands.
Yes, ma-channel,
My channels.
ma-channels aya. Pane rimwe band unless zesipafika yese ukaita hotspot, let's say on a Windows level. Pane mamwe ma-device unodauta what might be cheapable. Even Windows inoda kurecommenda kuti icha back to 2.4.
Right, question, it would be this band iri. Panpanga parisingashandi. Probably client inenge isina because the band iri rinoenderana nemastandard ane handita discuss amastandard 802 802.11 A B N N A C, right. A ne B probably inoshanda pa 2.4 chete. So kana uri kushandisa standard rine 2.4 chete, it means you cannot use the 5 gigahertz band. So it depends ne client kuti rine mode here in 5 gigahertz. Kana isina, then you cannot use that. Do you get the sense? So it's my standards here, the compatibility. Compatibility issue. So I think just to add a little bit more, my frequency, I think every standard there is a frequency 2.4. Mamwe ane 2.4 ne 2.5. Mamwe ane 5 chat. So we have mamwe ane 2.4 chat, mamwe ane dual, ni mamwe ane 5 chat. Is there one in the 5 chat? No, I don't think so. So pana ane 2.4 ne ane 2.4 zisine 5. So ukashandisa pa 5 gigahertz band, your device rako risina that standard kunoshandisa 5 gigahertz band. There's obviously an issue. That's why probably ku 2.4. I think so. Right, configuring a wireless mesh network. In a small home network, one wireless router may suffice to provide wireless access to all clients. But if you want to extend, then you need to add access points, therefore extending the LAN. Right. So let me put it this way. Let's start by defining wireless router radio access point again. Wireless router, we defined it as a device rinokwanisa to act as a router, as a switch, as an access point. it can offer all those functionalities, right? Wireless mesh here is just a network that you create so that you extend coverage network yako. Dai ndiri kushandisa wireless router, tomboti coverage yangu inenge yakangodai so wireless. If I add an AP, this AP, I've extended wireless network yangu. If I add another one there, I've extended wireless network yangu. So the wireless mesh network, it allows adding my access points so that you can extend network yangu. In this case, you can see these are wirelessly connected because a router can act as an access point, providing wireless access to another access point, etc., etc. I think we'll have a chance to create our own wireless mesh. We'll get there. Not much here. Let me see. Not for IPv4. I think we now all know what address translation is. Translating between public and private addresses. Pangati chichinja my default settings here, my private addresses that we're using. When you want to communicate over the internet, you need to use my public addresses. So our private addresses, our 192s, 168s, our 10, 10, our 172, etc., etc., they will need to be changed to be public addresses. And the good thing about wireless router, it has that capability to translate the private IP addresses to the public IP addresses. So these are the settings that we have. You can see the internet IP address. This is a public IP address that we have. Its default gateway, public as well. So the internet IP address is public, but network yedu inside, it will need to be translated from public to private. So that my clients here my IP addresses are private. And that's why we have NAT, basically. So NAT allows hosts on the LAN to communicate with the outside world. The router will use a process called network address translation. It translates private local source addresses to public, makes sharing one public IP address possible by tracking the source port numbers. That is PAT. If your ISP has reached IPv6 are enabled, you see a unique IPv6 address for each device. Basically here, NAT, we are just introducing NAT because our router, our wireless router, will need to perform that function so that we have a translation of our local and our global IP addresses. Router Red will also offer QoS, quality of service, prioritization of other traffic, of one traffic over the others, if I can say. By configuring QoS, you can guarantee that a certain type of traffic are prioritized over traffic that is not as time sensitive, such as email, web browsing. Some wireless routers traffic can also be prioritized on specific ports. So this is a GUI. I'm not sure here which type of wireless router interface, and you can see here, hi, iPhone traffic, Counter-Strike, Netflix traffic. This is gaming and streaming. Traffic here is being prioritized over the other traffic like FTP, www. I think that's website traffic is being prioritized over other traffic. So our wireless router is capable of configuring or having settings that configure prioritizing traffic over other types of traffic. And this is how you do it. Port forwarding, 4 minutes. Port forwarding. All right. Wireless routers typically block TCP and UDP ports to prevent unauthorized access in and out of the LAN. However, there are situations when specific ports must be opened. Port forwarding is a rule-based method of directing traffic between devices on separate network. Port triggering allows temporarily forwarding of that data. You can use port triggering to forward data to a computer only when a designated port range is used to make an outbound request. Right. Port forwarding. How do I put this? This is our router. This is our outside network. This is our inside network. This is our client. All right. If a device outside our network wants to get access to this PC, wireless router redu. Wireless router redu rinogona rine security settings aripo, so traffic inovhetwa traffic kuti should it pass through kuti iende ku our PC. At times TCP and UDP ports anenge akavharwa, they are blocked so that any type of traffic haingopindi in those specific ports. It's for security reasons, basically. So router redu rinenge reconfigured for specific reasons to block traffic imwe until yavhetwa, then yozopfuura. But at times you can open those ports so that if, let's say, a server, if my PC wants to get access to this server without scrutiny from router ready, ndinoya parouter and open my ports, specific ports, and router opener, so that if I request access to the server area, I get direct access to that server. Or if the server wants to get access to this PC, it gets direct access to that PC. That is what port forwarding is. It's basically opening my ports per my router's head up. For example, HTTP, I think HTTP is port 80. If you open port 80 per wireless router, it means my services are not often port 80. They won't have scrutiny from the router that much because that port is opened. So two types of forwarding that do open port forwarding. Two types of opening my ports, if I can say. Port forwarding, which is a permanent opening of the port. Port triggering is not permanent. That port is only open if there is a request to use that port. So you can see port triggering, I think it's much preferable than, just a minute. Right, port triggering is much preferable than port forwarding, because port forwarding, port rinenge rangovhurwa. The problem is that port rikangoramba rakavhurwa, intruders get access to that port and the network gets attacked. Advantages ekuti unowana direct access, yes, but port are open, security wise has make sense. So you can use port triggering, which temporarily opens that port. So if I want to use port 80, a request is sent, then a port is opened. Panopedzwa kuitwa transmission, that port is closed again. So that is port forwarding and port triggering, basically. And those configurations can be made on our wireless router. All right, let's continue with configuring a basic wireless LAN on a controller.